More than 1 century after the first suggestion of black holes by John Michell in 1783, physical evidence of black holes from collapses of stars at the end of their life have become cosmic realities. In 1974, Sagittarius A star became the first discovered physical black hole at the center of the Milky Way. According to Einstein's general relativity theory, black holes must harbor a singularity because this is an infinitesimal point into which matter collapses when spacetime curvature becomes infinite. Singularity is virtually considered nowadays as black holes must have fissure, since Einstein's general relativity theory has become a de facto law of classical gravity. However, the concept of singularity, despite its widespread acceptance so far, remains uncertain. Does singularity physically exist, as Einstein's general relativity theory claims, or is it just a mathematical artifact after all? On the contrary, based on my own finding, which is a potential discovery of a set of alternative equations to Einstein's field equation-based solution for the Mercury perihelion precession anomaly, physical black holes cannot harbor any singularity because there appears to exist a common cosmic action class that can explain the event horizon feature of black holes in a mundane way. With respect to black hole singularity, quantum gravitational kick is my alternative to Einstein's spacetime curvature breakdown. Based on my potential findings, there appears to exist a common cosmic action, which is a quantum push that every celestial object gives to its gravitationally bound one whenever the latter finishes one orbital revolution, hence the name quantum gravitational kick. The equation of the energy of the set quantum gravitational kick is 6 pi gm over c squared, where m is the mass of the kick-generating celestial object. This cosmic action is the cause of not only the Mercury perihelion precession anomaly, but also the black hole's actual event horizon, which is outside the event horizon from Schwarzschild's radius. The energy of the set quantum gravitational kick exerted on orbiting celestial objects must generate a ring of death around the black hole, specifically at a radius of 3 gm over c squared. From the center of the black hole, the generated ring of death will have an orbital length of 6 pi gm over c squared. Any intruding celestial object that reaches this gravitational kick orbit will be captured by the owning black hole, then will receive from the latter a kinetic push of length that is equal to the circumference of this fatal orbit. As the said intruding celestial object keeps revolving around the gravitational kick orbit, it will receive overlapping gravitational kicks. With accumulation of kinetic energy as a result, the celestial object must be physically more and more stretched out, hence the observed spaghettification phenomenon. At a certain level of density, no physical force will be sufficient to push matter through the event horizon to reach the center of the black hole. Vagabond celestial objects can keep getting sucked into the gravitational kick orbit, known as the event horizon, then grow the black hole indefinitely. This must be the reason why some observed black holes have gigantic masses of billions of suns. Based on my analysis, the quantum gravitational kick-based creation mechanism of black holes can explain why black holes are not vacuum cleaners. Only vagabond celestial objects that accidentally reach the gravitational kick orbit get stretched to pieces. Other celestial objects further away from the gravitational kick orbit remain safe and can be gravitationally bound to the black hole like those in most cosmic systems. All the relevant details regarding the research process, mathematical verifications, and demonstrations can be found in my book, Singularity-Free Black Holes Equation 6 pi gm over c squared, and in my other relevant book, Quantum Gravitational Kick 6 pi gm over c squared.